Okay, hi, we're going to take a look at another problem with solving by substitution. For this problem, the last video I did, it was had with what was y equals. I now have another problem here. Instead of saying that I've set this up for y, I've written the problem here for the system of x equals 2y plus 1, and I've got 3x minus 2y equals 15. And what I want to do here is I want to find the coordinate pair where this line intercepts this line. What I want you to note is that yes, both of these can be written into y equals mx plus b form, if I would solve for y here and solve for y here. But when I do that, I'm going to get fractions. So doing that, it's not necessarily going to be the most accurate way, because if I have fractions, then how do I know that I've completely, without a doubt, 100% drawn it on there? And it would take too long. So the most surefire way of doing this would be doing a method of substitution, and there's other methods as well that I'll discuss later. But x equals 2y plus 1. So again, same instance. I am looking for one of the variables to be defined as saying that this variable is this function. So what I have here is I have y, okay? I have x written as a function of y, meaning that x is the same thing as if I took 2 times the y variable and added 1, that would give me x. So what I'm going to do here is I'm going to note that this x variable right here, okay, and this x variable happen to be the same exact thing. And the reason, again, for that is because we're finding the point at which they intersect. So at the end of the day, I'm going to have to check, does that x-coordinate and that x-coordinate the same thing? And they have to be, because we're talking about where they intersect on a graph, and where they intersect on a graph is the same exact point. So that x-coordinate and that y-coordinate have to be exactly the same. So up here, I'm going to come up here and I'm going to go, okay, if that x equals 2y plus 1, well then this x is also 2y plus 1. And instead of writing it as 3 times x, I'm going to write it as 3 times its function, and its function is 2y plus 1. So the function of x, okay, is going to be this 3, and I'm going to be multiplying by what x's function is. And now x's function here, we take a look at it, is 2y plus 1. So that's what I'm substituting in for that y. And everything else remains the same. So I still have minus 2y equals 15. And the important thing to note here is that I left the 3. It is just the x. You can't replace this whole statement with 3x, because you have 3 of these 2y plus 1s, and up here you're talking about 1. So if that x and that x are the same, then I replace it in. So then I go ahead and now I've got a problem that has all y's in it, which is perfect. So I go ahead and do my distributive property. So I get 6y plus 3 minus 2y equals 15. So 6y minus 2y is 4y. So plus 3 equals 15. Subtract 3 from both sides, and what I'm left with is 4y equals 12. So divide 4 by both sides, and I have a final answer of y being equal to 3. So what I now have is that I've got this y equal to 3. So remember that I'm looking for the coordinate pair, because the solution to when lines intersect is at a coordinate. So I must write my solution as a coordinate pair. So I've got the y, which means the other thing I have to find for a coordinate pair is the x. And the way that I find the x is I come up here and I plug it in. So this now becomes 2 times 3 plus 1. Well, 2 times 3 is 6, and 6 plus 1 is 7, so that means x is equal to 7. So my final answer to this one is 7, 3. So the coordinate pair 7, 3 is the solution to this problem. So I hope that helps with any homeworks that you do.